Hello and welcome back to Getting Started with BGFX. I'm not going to show my face in this video because I have a big ugly cold sore above my lip and you really don't want to see that. But in the last video we initialized BGFX and we got it running in the background and we cleared the screen with a nice aqua color. What we want to do next is to get a square drawn to the screen, and this involves an index buffer, a vertex buffer and a shader program. Well, in this video we are going to create an index buffer. Now, if you already know what an index buffer is, then you can skip ahead to when we create it in code. But all shapes inside a computer are drawn using triangles. Even circles are drawn with a whole lot of triangles that are infinitely small. Now, back in the early days of rendering like OpenGL, each of those triangles was sent to the graphics hardware one at a time, one vertex at a time, because that's all the graphics hardware could handle, and a vertex is just simply a point on the triangle. But as the hardware evolved, it got more efficient to send all triangles to the graphics hardware in one big list. So a quad is made up of two triangles like this, and each triangle has three vertices like this. So the list of vertices sent to the graphics hardware would look like this. However, these two vertices are exactly the same, and these two vertices are exactly the same, and they only show up like this just to demonstrate that they are demonstrate how triangles look like inside a quad. But if we go back to the earlier quad, we can see that there are in fact two vertices here and two vertices here. They are just exactly the same. So if we eliminate the duplicate vertices, then we only send the four vertices of our quad like this. But that leads to another problem. How can we make triangles out of this? Well, alongside the vertices, we can give the indices of the vertices that make up the two triangles, like this. So our first triangle is made up of the vertex at index 3, then index 2, and index 0. So that's here, here, and here. And then the second triangle is made up of vertices at index 2, index 1, and index 0. And it is these indices that make up the index buffer, and the four vertices make up the vertex buffer. Now, the eagle eyes among you would see that the vertices are in a counterclockwise order. See, this triangle here starts here, goes along to here, and goes here. This triangle starts here, goes up to here, and goes here. This is correct as you can't give the vertices in any order. The default behavior is a triangle is considered facing towards you if you are looking at the vertices in a counterclockwise order. If you flip the triangle around, then those vertices will now be in a clockwise order, and you won't be able to see it until you come around to the other side. This can be changed, but the default behavior is the counterclockwise order. But why would we do all this? Well, a vertex is typically made up of a position, a color, and texture coordinates. The position is made up of three floats, one for the X, one for the Y, and one for the Z, and a float is 4 bytes long, so the position is 12 bytes. The color is a 32-bit integer, which is another 4 bytes. The texture coordinates is made up of 2 bytes, made up of two floats, one for the X and one for the Y position of whatever pixel of the pixel inside whatever texture we're using. So that is another 8 bytes. So if we add all that up, that is 24 bytes per vertex. Sending all 6 vertices for both triangles would be a total of 144 bytes per square. However, sending only 4 vertices would be 96 bytes, and each index is only 32 bits, which is 4 bytes, giving a total of 24 bytes for the vertex buffer, which would only be a total of 120 bytes for the square. If we were using 16 bits for the integers inside the indices, there would be 12 bytes, which will only be a total of 108 bytes for each square. So it may seem like a lot of work to save a few bytes of memory, but it adds up when we're dealing with millions of triangles that the graphics hardware can handle. Anyway, that's enough talk. Let's dive into the code and we will create an index buffer. So if we go into our project, we'll need to do it after we've initialized BGFX, so we'll do it right here. First we need to create a list of indices. So we'll do uint 16 underscore t indices equal indices square bracket 6 equals brace 3 2 0 2 1 0. Then we create an index buffer like this: BGFX : index buffer handle index buffer equals BGFX : create index buffer open bracket BGFX : make ref open bracket indices 12 close brackets semicolon. So what is this makeref doing? There are 2 ways we can give data to BGFX. We can use makeref and we can use copy. Both ways we have to tell it how much data we are giving, and in our example we are giving it 6 16-bit integers, which is 12 bytes. So 16 bits is 2 bytes, so it's 2 bytes per index, and we're giving 6 of them, so that's 12 bytes total. But we use makeref when we retain control of the data. We just have to make sure that the data is not destroyed while we're using it. I've fallen into that trap many times where I'm wondering what's going on here, and I realize that I'm actually destroying the data while I'm still using it. We use copy when we don't care about controlling the data, and BGFX will destroy the data when we have destroyed whatever component is using it. But for our example, we've created the list, we're going to retain control of it, so we make a ref to that list. So now that we have created it, we need to check if it's valid. So we do it like this: if open bracket BGFX : is valid open bracket index buffer equals false. So this will return false if it's not valid, so we'll just print an error message: could not create index buffer. Then we'll return 1. So this is valid function works for the index buffer, works for shaders, works for frame buffers, textures. So you just pass in the handle and check to see if it's valid. Now before we shut down BGFX, we have to destroy this. So we go BGFX : destroy the index buffer. And that's it. Alright, let's run this. And no error messages. That means that we created our index buffer successfully. Now you need to destroy this because BGFX will complain about memory leaks when it's shutting down. Now for our example, we destroy everything just before the program is terminated, so it doesn't matter that much, but it's still good practice to manage the memory properly. Alright, so that's it for this video. In the next video, we'll be looking at creating a vertex buffer, which is the second component we need to draw stuff to the screen. I will push everything to GitHub, and I will see you in the next video.